Hi, this is Dr. Kunka Bheemalingappa, faculty of CSE. I heartily welcome to you. In this video, I am going to discuss about minimization of DFA. How to minimize the DFA. These are the contents. First, we are going to look at what is DFA and how to minimize the DFA. Suppose we have a regular expression A or B star ABB. The NFA for this regular expression is this. In one of the previous video, I have discussed about how to convert NFA to DFA. There I have taken this same regular expression. Here also I have taken the same regular expression. This is the NFA. What is the language that is described by this regular expression is this. Any combination of A's and B's followed by ABB. That is the language that is defined by this regular expression. So the possible strings of this language are just ABB, or we can have here this star means 0 or more times. So I have taken this ARB part 0 time. So we got a string that is ABB. If I take this ARB 1 time, then I may get a string that is AABB. In any string, this ABB is a must. It can be preceded with any combination of A's and B's. You may have a string like say BABB. This is also a string, or any combination of A's and B's like say AB. But every string must end with that is ABB. So this is the language denoted by this expression, and this is the NFA. But mainly we are interested in conversion of, that is minimization of DFA. So first let me take DFA for the same expression. The DFA for this expression is this. This is a start state. Let me use the numbers for denoting the states. So this is the DFA which corresponds to this regular expression. It also accepts the same language. Any number of A's and B's of any combination ending with that is ABB. Here this 5 is the final state. 1 is the start state. So now first we can take the transition table of this DFA. The transition table of this DFA is this. Yeah, here I can write. The transition table of this DFA is this. The states are 1, 2, 3, 4, 5, and we are known that 1 is the start state. This 5 is the final state. Input symbols are A, B. Okay. So from 1 on A you are going to state 2. From state 1 on input symbol B you are going to state 3. From state 2 on input symbol A, you are going to state 2 itself. From state 2 on input symbol B, you are going to state 4. From state 3 on input symbol A, you are going to state 2. From state 3 on input symbol B, you are going to state 3 itself. From state 4 on input A, you are going to state 2. From state 4 on input B, you are going to state 5. From state 5 on input A, you are going to state 2. From state 5 on input B, you are going to state 3. And you are known, there is one and only one final state, that is 5 here. This is a transition table of this DFA. In minimizing DFA, what you are supposed to do is, first you have to separate final and non-final states. And we are known that you have only one final state, that is 5. We have one and only one final state, that is 5. That you can take it as one separate group. And you can take the rest of the states as another group. Rest of the states are what? 1, 2, 3, and 4. 1, 2, 3, 4. So this is non-final group and this is a final group. In the final group, you have only one state, whereas in non-final group, you have 4 states. In this, if you look at the table carefully, that is a state 1 and state 3. They have same transitions in the table. That is, for state 1 on input symbol AB, you have 2, 3. For state 3 on input symbol AB, you have 2, 3 respectively. So they have the same entries. In the sense, I can group this 1, 3 as one group, 1, 3 as one group, and rest of the states, you are left with 2, 4. I'm going to take them as separate group. And this group as it is. Coming to this 1, 3 being they are having same entries in the table, I can replace 1 with 3 or say 3 with 1. Anything it can be done. It is up to you. Otherwise, if you want to replace the entire thing, that is 1, 3 with some other number, say 6, you can replace it. So by doing so, what will happen? Wherever this 1, 3 is there in the table, there you can take a new state. Let me call it as, say, for example, 6. Right? Then you will have the states 6 or 2, 4. If you look at the entries in the table of states 2 and 4, for on input symbol A, they have same entry, that is 2 on A is 2, 4 on A is 2, but they differ with respect to the input symbol, that is B, that is 2 on B is 4, 4 on B is 5. So they are different. So you cannot group this 2 and 4. So you can take this 2 and 4 separately. So this is as it is, non-final state, final state group. So finally, you are going to have the states 6, 2, 4, and 5. Yeah. Now, if you reconstruct this table, these are the new states, right, that what you are going to have. What are the new states? Wherever this 1 or 3 is there, in that place, you take that, new state, that is 6. And you are known, this 1 is a start state, therefore, this 6 becomes, that is, start state. Right. input symbols are AB. 6 on, yeah, just in place of 1, 3, you have to take, that is 6. In rest of the other place, you have to take as it is. So this 2 is okay as it is. In place of 3, I have to take 6. So you are known what states you have. 2, 4, 5. That is 6, 2, 4, 5. So for state 6, I have defined this okay transition. In a similar fashion, you have to define the transition for rest of the states. So 2 on A, just take this table. Wherever this 1 or 3 is there, just in place of that you take 6, rest are same. So in all these places you have 2 itself, therefore I have taken that to 2 itself. And 2 on B, here you have that is a 4, so that is okay as it is. But here 3, you don't have that, what, that is I am combining this 1 and 3. I am combining this 1 and 3 and renamed it as what, that is a 6. So this 1 and 3, that is okay. In place of this 1, 3, I have got that is okay 6. For that I have defined. Next, coming to this 4, 4 on A is 2, 4 on B is what? 5. Next, 5 on A is okay 2, I have defined. 5 on B is 3. Wherever this 1 or 3 is there, you are supposed to take it as okay 6. Therefore, you have got this. And you know, you are known this is 5 is the final state. This 5 is the final state. So this is the minimized DFA. So in a DFA, you have 5 states, whereas in this minimized DFA, you have only 4 states. But they both should accept the same language. They both should accept the same language. First, let me draw the transition diagram of this. So 6, that is the start state. On A, you are going to what? State to 2. On B, where you are going? You are going to state 6 itself. Next, 2 on A, where you are going? You are going to the state 2 itself. 2 on B, you are going to a state 4. Next, 4 on A, you are going to state 2, that is this. Next, 4 on B, you are going to state 5, and you are known this 5 is a final state. Let me use a different color for that. This 5 is a final state, right? Yeah. And also here, this is a final state. That is, final states are okay, double circuit. You just remember. Yeah. Next, 5 on A, where you are going, that is 2. Next, 5 on B, where you are going, that is 6. That is the state itself. 5 on B. So these are some possible things. A, B, B, it is going to be accepted in this way. This is a start state. A, B, B. If I take say A, B, B, it is going to be accepted in this fashion. A, B, B, like this. If I take say B, A, B, B, it is going to be accepted in this fashion. That is B. Now it is more clear. A, B, B, how it is going to be accepted, I am going to show here. That is A, B, A, B, B, in this fashion. So it is also accepting the same language, but when compared to this, it has less number of states. Both are DFAs, but being it is having less number of states, I am calling this as a minimized DFA. So here you have 5 states, whereas here you have, that is 4 states. I hope you understood. So for a given regular expression, whenever you have designed this NFA, DFA or minimized DFA, all they must accept the same language. Whatever that is described by that regular expression, it must be defined, it must be, if you take some string which belongs to that regular expression, then that regular, if you take some string belongs to that regular expression, that string must be acceptable by all this, that is NFA, DFA as well as minimized DFA. I hope you are clear. Yeah. Suppose I have given this as okay DFA, and if I ask you minimize this DFA, then is it possible to minimize? Is it possible to minimize? You just have to think over that. There may be the case it cannot be minimized. So you have to be so careful. For example, for this one, right, we can test on your own. You may think that for the states 6 and 5 in the table, you have same entries. You know this 5 is a final state, this 6 is a non-final state. They cannot be combined, right? So it cannot be further simplified. So if there is a possibility for you to minimize DFA, you can minimize. Otherwise, you can say that it is further, it cannot be minimized, right? I think I understood. So whenever someone asked, right, can you minimize this? You don't think that definitely it is going to be minimized. It may or may not be, right? I think I understood this. Yeah. I hope it is clear to you. Let me take one more example, because here you have only one final state. Let me take some example which consists more than one final state. Then it is going to be more clear. Now let me take the regular expression A star B or B A star. Suppose you have this regular expression. I'm going to give DFA for this, and we are going to see how to minimize the DFA. First, let us know what are the possible strings of this language. What it says, any number of A's ending with single B, or a single B followed by any number of A's. That are the possible strings of this language. So let me write down this possible strings of this language. That is, you can have single B or one or more number of A's followed by single B. So here I have taken one number of A. You may have say more than one number of A, but one or more number of A's ending with B, that is this. Or you may have strings of the form what? B followed by any number of A's. For example, B followed by single A. This B is a mandatory. Or B followed by, here one number of A. This is B followed by two number of A's. Like this you can have any number of, any string like that is B is followed by any number of A's. I have shown with example that is 1A, 2A, and then any number of A's. So these are some possible strings of this language. Let me give DFA of this regular expression directly. So this is a start state. Let me take it as 1. What we have here, any number of A's followed by single B. Any number of A's followed by single B. So this is the final state. I'm going to use a different color. Yeah. Being this is the final state. First let me double circle, later I can use like a different color. I can. Yeah. And you can have A, B or any number of A's followed by this any number of A's followed by a single B. They are the strings, okay, that are acceptable by this. In a similar fashion, we can have, there is single B must be acceptable. That is this. We have the strings of the form B followed by any number of A's. So this is a final state. B followed by any number of A's. You may have say single A or any number of A's. This is a final state. If you want to give numbering for the states, you can give this is 1, this is 2. If you want to give this as 3, you can give. And for this, if you want to give it as a 4, you can give. And this is a 5. Right? For final states, let me use a different color. These are the final states. In the previous case, you had only one final state, but in this case, you have 3 final states. In this case, you have 3 final states. Let me take the transition table of this DFA. You know what is this? What is DFA? For a given input and state, you are supposed to have one and only one outgoing transition. So from the state, outgoing transition means what? The arrow pointing away from the state. Right? That is outgoing transition of a state, we can say. Yeah. So let me take this transition table, that is delta. You are known what are the states you have? 1, 2, 3, 4 and 5. These are 5 states that what you have, and you are known one is a start state, one is a start state. This 3, 4, 5 are final states. Final states are doubled circle in the transition diagram. In the table, you can use single circle, or you can, some people they use star also. It is up to you. And coming to these input symbols, you have 2 different input symbols, A and B, right? From the diagram, you can get the entries of this table. 1 on A, where you are going to the state 2. 1 on B, where you are going to state 4. This is 4. I think it is clear. This is 4. 2 on A, where you are going? 2 itself. 2 on B, where you are going? 3. 3 on A, you are not going anywhere. Leave it. Next, 4 on A, where you are going? 5. 4 on B, no, empty. 5 on A, you are going to what? State 5 itself. State 5 itself. So this is the transition table of this DFA. This is the transition table of this DFA. That is delta for this DFA. Transition function is what? Q by sigma. These are Q. This is sigma. Right? Yeah. What you are supposed to do? You are supposed to separate final and non-final states. You are known 1 and 2 are non-final states. You can take them as one group. And rest of the states 3, 4 and 5, all they are what? Final states. Final states. In 1, 2, if you look at the entries of states 1, 2 in the table, on A they have same. Let me show that eraser pointer. Yeah. On A, 1 and 2 they have same, but they differ on B. Therefore, right, you cannot group them, right? You have to take them separately. Yeah. And coming to this 3, 4, 5, if you carefully watch this 4 and 5, on A, they have same state here, that is 5 itself. On B, that is empty. So, in that is, if you carefully watch the rows of this state 4 and 5, they have same entry for A and B. So, I can group this 4 and 5 into 1 and rename it with what name? With what name, right, you want to rename? Yeah. I can combine this 4 and 5. I can combine this, okay, 4 and 5 into 1. 3 I cannot combine. And this 1, 2 also I cannot combine. They are, okay, different. So, I am going to, okay, split 1 as well as, okay, 2. And in place of this 4, 5, if you want to take some other name or any one of these two names, either 4 or 5 or some other new name in the sense that is, okay, 6, you can take. Suppose, for example, let me take a new state name, say that is 6. So, in the table, wherever this 4 and 5 it is there, you are supposed to take it as that is a 6, right? Now, what are the states that what you are going to have in the minimized DFA? Now, I am going to, from this, I am going to define what is this transition table of this minimized DFA. 1, 2, 3, these are states, and 6, that is a new state. And you are known, what are the input symbols that you have? That is A, that is B, okay, A, B. From the table also you can. So, 1 on A is what? That is 2. So, no change with respect to this. Just in the table, wherever this 4 or 5 is there, just in place of that, you have to take 6. So, here 4, therefore, I have to take it 6. Next, 2. This is 2. This is, okay, 3. You have to be careful about that is 4 and 5, right? So, this is 3. No transitions, leave that. And then, so 5 in the sense the what? That is 6. Here you have 5. Okay, 4 or 5 in the sense that is 6. So, 6 on A is what? 6 itself. And the 6 on B is that is blank. Okay, as it is. So, these are the new states that what you are going to have. And from this one, I am going to draw this, okay, transition diagram. You know what are the, so, you know this 4, 5 are final state group. Therefore, this 6 is going to be a what? Final state. 1 is like a start state. And this 6 is going to be a what? Final state. 6 is going to be a final state. And you are also known that this 3 is a final state. 3 is a final state. Therefore, this 3 will also become a final state. Now, let me draw this table from state 1 on input A. You can go to state 2. From 1 on input B, this is B, this is 6, right? This is input symbol. 1 on B, you can go to state 6. 2 on A, you can go to state 2 itself. 2 on B, you can go to state 3. 2 on B, you can go to state 3, and you are known this state 3 is a final state. For 3, you don't have any transitions. For 6, on A, you are going to what? 6 itself. And you are known that this 6 is also a final state. So I can use a different color. So first let me use a different color. Yeah. So this is the final state, and this is also a final state. So this is a minimized DFA. This is minimized DFA. Let M stands for minimized, then I can write it as what? Minimized DFA, that is this. They both should accept the same language. You are known what are the possible strings of this language. Take for example single B. From 1, you are going to this state, and you are known this is a final state. If you take string say AB, so this is A. Let me change this cursor so that you can laser pointer. Yeah. If I take this B, it is going to be accepted like this. If I take AB, A, B, so this is a final state. Any number of A's ending with single, followed by single B. So first A, second A, third A, any number of A's ending with single B, followed by that is single B. That is, you are going to be there in final state itself, right? So that is this. And then BA, B, A. B followed by any number of A's, 1, 2, 3, any number of A's. So all these are acceptable. So if you take some string which does not belong to this language, it is not supposed to accept, right? It is not supposed to accept. Can you tell me some strings? You are known, these are the some possible strings of this language. Can you tell me some string which does not belong to this language? Either it should begin with B, or it should end with B. You are known that. But if I take some string, suppose if you take a string, okay, ABA, is that ABA belongs to this language? Is that it is going to be defined by this regular expression? No. So if you try to process that, then you are not going to be end in a final state. Suppose for example on A you are going here, on B you are going here. So on A you don't have any transition. You are unable to read that, okay, third symbol A. That's what. I think you have understood. So I have taken 2 cases where you have a single final state and also you have more than one final state. I hope you have understood more clearly and you have seen. And coming to this conclusion, DFA and minimized DFA, they both should accept the same language. The major difference between this DFA and minimized DFA is that the minimized DFA will have less number of states when compared to the DFA, but they both should accept the same language. That's all. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.